Welcome to another episode of our podcast, Power On. Our today's topic is distribution grids and challenges and changes which are currently ongoing. My today's guest is Franco Pizzutto. Hi, Franco. Great to have you here.
Hi, Christian. Thanks for inviting me.
Franco, everyone is talking about the energy transition. How long have you personally been involved into this topic, and which changes you might have seen in your career time?
I've been involved in the topic now for 12 years.
Wow.
And the changes that have occurred or that I've seen or I've witnessed are more visibility for the low voltage network.
Okay.
More importance, let's say, and more actuators, the demand for more flexibility, and less safety margin.
So there were a few topics you mentioned. So there was less awareness the last couple of years for this distribution grid?
Yes, at least as far as I understood it.
Yeah.
Network planners would have their standard planning procedure for the low voltage network, and based on experience, and that worked for the last decades. But with the energy transition and the distributed generation units in the network, in the distribution network, this has brought a paradigm shift to the network, because these planning principles are getting to their limits now, and are restricting the hosting capacity of the network for these generators, but also for innovative loads like EV chargers and heat pumps. So the hosting capacity for these units is quite low. And therefore, the challenge of the network operator is either to proceed with the same principles and reinforce the network a lot, or change their approach and have a closer look, let's say, in the network planning, or give more flexibility with different assets. For instance, a voltage regulating distribution transformer that allows more hosting capacity while at the same time keeping the network infrastructure, so by keeping the installed cables as they are.
So a voltage regulating distribution transformer, in short, it's a VRDT.
Yeah.
What is the difference of this VRDT compared to the normal one, or the ones we already have in the distribution network?
So the DT, the non-regulating distribution transformer, also has a tap changer installed, but a de-energized tap changer or off-circuit tap changer. So you need to switch off the transformer in order to adjust the position of the tap changer and therefore the ratio of the transformer. And this you might do when you have a greater change in your network, additional households being connected, and therefore you adjust once the position. But during operation, once the transformer is switched on, you cannot change the ratio. A voltage regulating distribution transformer is equipped with an on-load tap changer. This is a technology that is well known in the transmission grid. Now for nearly 100 years.
Yeah.
They have been in operation. And these devices can change the ratio of the transformer under load, and therefore during the normal operation of the transformer. And therefore you can change or adjust the voltage output of the transformer according to the actual situation.
So I do not have to go on site and have to switch off this transformer. I can do it from the control room.
No, actually, you don't want to do it from the control room. Because when we're talking about the distribution network, we're talking about thousands of secondary substations, and therefore thousands of or tens of thousands of distribution transformers. You cannot manage to to change the ratio for each transformers from the control room. You want them to work autonomously. So you have a voltage regulator installed at the distribution transformer that makes sure that the output voltage is according to a certain set point.
Mm-hmm.
Yeah,
so and he's adjusting and measuring this by himself.
Yeah, that's an autonomous decentralized system. So there's not even the need of communication for the unit to work.
Oh, it's very, very smart then, huh?
Yeah, because otherwise, if you have to rely on communication in order to make your distribution transformer regulate the voltage, what will you do as soon as communication fails? Because communication can fail.
Mm-hmm.
And the cost of establishing redundant communication channels for these many for that many units is massive.
Mm-hmm.
So therefore, you want your unit to work autonomously. Otherwise, you cannot use the benefits as soon as the communication fails. Therefore,
makes a lot of sense.
It makes sense to have let's say communication for monitoring, for instance, or maybe adjusting once in a while maybe the set point, but not even that is used by most customers. Most customers have their planning principles that are according to a certain set point.
Mm-hmm.
And this is the biggest change that the VRDT brings for the customers. They can plan differently. They can increase, for instance, the voltage drop and the voltage rise that they can allow in the network if they're using a VRDT. And these planning principles are based on certain settings or certain parameters. And these parameters are set on the device. And you basically fit and forget. So you install the unit, set the parameters, and let it do its job.
Okay. Can I replace a non-regulated or one with an off-circuit tap changer easily with one with an on-load tap changer from size perspective, footprint perspective?
So that was one of the main tasks or the main requirements that we received from our pilot projects. So when we were developing an on-load tap changer for voltage regulating distribution transformers, the main requirement of the DSO was that it should be maintenance free. So it should not increase the requirement on maintenance compared to a non-regulated one.
Okay.
It should neither decrease the lifetime of the transformer compared to a non-regulated. And the third thing was that the regulating transformer should have at least the same footprint as the non-regulated, as many distribution transformers are installed in compact substations. And therefore, you do the basic idea of the VRDT is to keep the infrastructure as it is. So keep the cable where it is. No need for additional cable.
Okay.
Keep the substation as it is. No need for additional substations, because that would be a conventional approach to the challenges. Reinforce the network, install more cable, maybe install additional substations. The idea of a VRDT is to keep the infrastructure as it is. And that includes the substation as well. So it would not make sense to create a VRDT that requires a bigger substation.
Yeah, because it increased the costs,
of
planning.
Course. And the idea is just replace the non-regulated transformer by a regulating transformer. And therefore, the footprint requirement.
So this was the requirements which you mentioned, maintenance-free, footprint and so on, this all can be fulfilled.
Yes,
right?
This can be fulfilled.
That's a lot of benefits. No? So for the customers, for example, or for the network planners, whomever. The VRDTs are becoming important for Germany. There we see it here and there, but is there any other country in the world where it's also important? Is this a global topic?
Yes, basically, it's linked to, let's say, VRDTs are driven by the energy transition. So where in networks where you see more and more renewable generation, and therefore you need more where you need more hosting capacity in the network.
It's coming from wind, solar.
Yes.
Okay.
But also on the load side, where EV charging and electric heat pumps are being installed. But not only. So having available this compact on-load tap changer, operators who are not necessarily driven, let's say, by the energy transition, see the benefits of voltage regulating distribution transformers as well. For instance, this is not related to network operators, but for instance to industrial plants where the power plant owners own also their the transformer, so they have a medium voltage connection, for instance. They also see the benefit of regulating their transformer in order to stabilize the processes. But as I said, in all the networks where renewables are rising, this is something where the demand for VRDT is increasing. And as you already mentioned, the major share of the installed VRDTs currently is in Europe. But VRDTs are being installed on all continents in the world. And also there, the demand for VRDTs is increasing dramatically.
Okay. This is very important if it's a global topic now. So it's not influencing only Germany. It's a topic around the globe. Were you involved in any specific project where there was a benefit directly visible, or a customer where came back and told you something, oh, this and this changed on a positive side because he installed a VRDT?
Well, again, if we look at industrial customers, we got a lot of feedback that processes are stabilized, machines didn't switch off due to too low voltage. But of course, also in the distribution network, where the main application of VRDTs is, we get the feedback that VRDTs are, let's say, quite easy to be installed, as it's a known technology. Distribution network operators or network operators in general know on-load tap changes from their power transformers in the primary substations, and therefore they are quite familiar with the concept of a voltage regulating distribution transformer and also with a tap changer. So this is one of the main feedbacks that we get, that the installation and the commissioning is straightforward. And the units, once have been commissioned, they do their job and work. And that's, let's say, the benefit on the network level, on the technical level, that the hosting capacity increases and voltage violations can be solved by simply installing a regulated distribution transformer. Other feedbacks are on the organizational level, because the main benefit of a VRDT really comes if the network operator integrates the VRDT in their strategic network planning. So not only measure to measure, so not only event to event to decide, okay, what is better, network reinforcement or installation of a VRDT. The main benefit comes when VRDTs are an integral part of the strategy, of the planning. So therefore, for instance, customers started to, or network operators started to define key parameters, which would define, which would set the VRDT as a default for networks where they had to do something, or where they would do modernization anyway, and where the transformer would need to be replaced. And these
standardized then.
These utilities would say, based on, I don't know, the rating of the transformer, or the number of feeders, or the length of the longest feeder. That is a so-called VRDT network. We will install a VRDT there, and afterwards look if network reinforcement might be necessary or not, because that's the main effect of the VRDT. It makes network reinforcement obsolete, or at least postpones measures and reduces the number of measures that you need to take.
I think this is important to know, that you can use it as a strategic approach, or include it in your strategic approach. No?
Yeah, of course. Yeah, because otherwise you have benefits there, but they're not as big as if you implement it. And this is another main requirement on our product. Let's say on us as a supplier. The high degree of standardization. DNOs like to work with standards. So at the one side, the unit should be as capable as possible to give as much benefit as possible, to give, let's say, a big regulating range, to gain as much additional hosting capacity to the network as possible. But at the same time, the specification, there is a unique specification for the distribution transformer. There is not a specification for that kind of networks and that kind of networks and that kind of networks within a company. There's one type with one setting with a certain number of positions and a certain regulating range, and the staff in the field wants to have always the same device in front of them and not different devices. So standardization is a big thing, and this is also something that VRDTs need to be. They need highly standardized, not only from the cost perspective, because if you produce a highly standardized product, you can offer it, of course, more economically compared to a product with high number of variants. But also from the operational point of view, if you have a high standard of degree, then you have easier life in terms of operation.
Yeah, I can understand that, because the people that know the transformer, for example, and if they're all the same, they know the equipment already, and if you mix it up, you bring more variants into that.
You need more training.
Yeah, all that things come.
People need to remember more different things,
and especially with the current topic, the war for talents, it's get even more complicated to get a qualified personnel, and to train them on 3, 4, 5, 6 different things is just more headache than for everybody. That makes a lot of sense, and if we can fulfill that with the VRDT, this is amazing, I think. I know it's always hard to look into the future, Franco, but where do you see currently the industry is going to, for example, the next 3 to 5 years? Is there any trend already ongoing which you see which getting stronger, or is there something where you think personally it's coming up in the future?
Well, as I said in the beginning, we already see the distribution network, the low voltage network, getting more and more awareness.
This will increase more, you think?
Yes, I think in some countries we already at a level where the awareness is already cannot be increased anymore. So this is something. Flexibility is a big thing in the network. So in order to answer to the dynamic generation, you want to have more flexibility in terms of consumption as well,
right,
in order to balance the network. This brings us again to the topic hosting capacity, because if your network is completely full without any more headspace, and with the hosting capacity already on the limit, you don't have much space to pass through this flexibility. So flexibility needs also hosting capacity. More visibility. In the past, if there was something wrong in the secondary substation, the network operator would not get an alert by some SCADA system. He would get an alert by a customer calling him and saying there's something wrong with my electricity or with my power supply. This already has changed. So nearly all network operators are digitizing their secondary substations in order to see what's happening. Smart meters is standard already. So this will be ongoing. More automized reaction, let's say, because you have thousands, 10,000s of substations. You need a computer, or you need something automated to take care of certain things at a certain level, at least. This is definitely coming. Yeah, and I guess that more and more secondary substations will be regulated.
Okay.
And voltage regulation in the distribution network will become a standard, simply because it's the only let's say level on the network where it's not regulated up to now, and this creates headache. So transmission network, everything.
We know the onload tap changer. Yeah.
It's then there are some countries or some network operators who do not use that. You could also run an electricity network without tap changers or without voltage regulation. You would have to simply install more cable, more network. You would have to install more reactive power equipment, but that would be costly.
So this is apparently for sure more.
Apparently, voltage regulation makes life easier, and therefore I don't see any reason why this should not happen also in the secondary substations. This is something that I'm convinced that will be there, and also because it gives there is free planning headroom available quite easily by just decoupling the medium voltage from the low voltage. Because currently the medium voltage is regulated, and every variation in the medium voltage is passed 1-to-1 through the non-regulating transformer to the low voltage, and that gives you big constraints in how you can plan your network. And by simply decoupling this by using a VRDT, there is plenty of additional headroom available for the network planner, which not only, as I said, solves the technical problems, but also
the strategic approach.
But also facilitates the network planning and speeds up the network planning processes
by standardizing all that.
By giving more hosting capacity, by, let's say, giving more safety margin. You can save a lot of planning time by saying, okay, if there's another application, I don't know, for a renewable energy generator in the low voltage, I have a VRDT installed there. I don't have to take care about additional or about a detailed calculation on the network. As long as the share of renewable generators in that network is not higher than, then you can quite easily allow this connection.
It's quite simple then,
and this makes things easier for the DSO.
So to summarize that, so we will see more automation in that topic, more intelligence. What we already see, more VRDTs in the future,
more actuators. Yes,
then for sure here and there more or different strategic approaches. That's I'm happy to look forward what the future will bring in, especially for this topic now, the distribution network. Thank you, Franco, for this interesting chat what we had today. To all who were listening or watching us, I hope, or we hope, that you enjoyed this episode from our podcast Power On. If you have any comments or suggestions, leave a comment, leave a like, reach out to our experts around the globe, directly to Franco if you like, or directly to me. It was a pleasure to have you here, Franco, again. See you in the one or the other episode. Thank you for watching or listening. Goodbye.